Welcome to EDU World Space.
For this question, we've been given n is 24. The standard deviation given to us, sample standard deviation, is 2.3. Since n is 24, degrees of freedom is 23. And since we're finding a 90% confidence interval, alpha is 0.1. Using these, now we find the two critical values from the G table. Chi-square alpha by 2 becomes chi-square 0.05 with degrees of freedom 23. Checking the G table, this value is 35.1725. Now, chi-square 1 minus alpha by 2 is chi-square 0.95 with degrees of freedom 23. Checking the G table, this value is 13.0905. Now we have the two critical values we need. Now we can move on to finding the confidence interval for the population variance. To do that, we use this formula. Substituting the values we have, we get this right here. Now, if you simplify this, if you simplify the expression we have here to get the confidence interval for the variance, you'll see that the confidence interval we get is 3.4592 as the lower boundary and 9.2945 as the upper boundary. Now, this is the confidence interval for the population variance. Now, to find the confidence interval for the population standard deviation, we take the square root of the confidence interval we have for the population variance. Let's do that. So we get square root of 3.4592 is the lower limit, which is less than equal to the population standard deviation, which would be less than equal to the upper limit, which is square root of 9.2945. If you solve this, you'll see that the boundaries for a confidence interval for the population standard deviation are 1.8. Oops, let me fix this. 1.8599 as the lower limit, and the upper limit we get is 3.0487. So here we found the confidence interval for the population variance and the population standard deviation.